How you doing? I'm Marc Etkind. I'm the CEO of the Computer History Museum, and welcome to everybody in person. Also welcome to all our friends online. And wow, look at this crowd. We have a full house here, and I think this crowd is a testament to what we do at CHM. There's a lot of places to get news on AI right now, but we are the only place that gives you that full story, that past, that present, that future. We decode the past to understand the present and to help shape the future. Thank you. Yeah, thank you. Yeah. Well, you're gonna like this even more, because central to what we do at CHM is our incredible collection. We have 1 million objects in our collection, and we've been collecting around AI for 30 years. So we have almost a complete story of AI. We have a connection machine. We have a list machine. We have the Stanford arm. We have my favorite, the legendary shaky robot. We have 2 miles of documents. And again, many of those are about AI. We have early papers on the development of AI. We have papers on Siri. We have papers on IBM Watson, and so much more. And of course, we have our legendary oral history collection. 1,400 oral histories. Again, many of those with the legends of AI, like Marvin Minsky and Ed Feigenbaum, and so many more. Now, what this 30 years of collection tells us is what the subject of tonight's event is, that the boom in AI that we're experiencing right now didn't happen overnight. It's been a roller coaster to get to today. So it's going to be a great panel going into all of that. Now, I want to give a huge shout out to the supporters of tonight's event, Marc and Mary Stevens. Their gifts have allowed us to collect around AI, to do events around AI, and they've created an endowment in business history. So please, a huge thanks for Marc and Mary Stevens. Thank you. So lastly, I'd like to introduce our moderator. Unfortunately, John Markoff is sick. Wait, we can do even better. We have Marc Weber. Marc is our curator of internet history. He's been studying how internet companies have been using AI, and he's the co-curator of our AI exhibit, Chatbot Decoded. So welcome, Marc.
Thank you, Marc, for the excellent introduction. It's an honor to introduce our distinguished speakers tonight. So first up is Jerry Kaplan, co-founder of Teknowledge, the publicly traded AI company that helped ignite the 1980s expert systems boom. He wrote Startup, a Silicon Valley adventure about his next company, pioneering mobile maker Go Corporation. Thank you, Jerry.
Nice to see you.
And next, Adam Cheyer, co-founder of Siri Incorporated, the groundbreaking intelligent assistant later acquired by Apple, and Viv Labs acquired by Samsung. Cheyer's work has been instrumental in bringing what is now called agentic AI to mainstream consumers. And then for the recent era, we have Daniela Roos, a robotics luminary, co-founder of Liquid AI. In 2023, she began building products around a potentially more flexible AI approach called liquid neural networks. She's director of MIT's Computer Science and Artificial Intelligence Laboratory, pronounced CSAIL, and has co-founded 3 other companies. Thank you. So I'm wishing John Markoff a speedy recovery, and I'm really sorry he can't moderate this wonderful panel that he helped me create. I first met him nearly 30 years ago in another boom, when we interviewed him for his role in web history. Many of these questions are his and draw on his deep and unique experience. So to a lot of people today, the AI boom feels like a first time. But for insiders, it's a sense of déjà vu over and over again. From the dawn of the digital computer, people have gotten excited about the idea of giant brains, which can either augment or potentially replace our own intelligence. And time and again, reality has fallen short of hype, creating so-called AI winters. Early winters made the term artificial intelligence itself toxic for funders and investors, which meant that a lot of advances in AI have happened under different names, from voice recognition to expert systems to intelligent assistants. That also meant that when internet companies began to use AI as the core of their business model, they too avoided the A word and talked of search algorithms and statistical machine learning and contextual advertising, eventually deep learning. So only in the past few years has the term artificial intelligence fully reemerged. And that means tonight we can ask entrepreneurs from 3 different generations of AI booms what is the same and what is different. But first, we want to ask you, the audience, a couple of questions. So do you think we're in an AI bubble right now? No. Yes, it's giving .com déjà vu. Not sure, depends how my AI stocks are doing. Or no, we're just getting warmed up by GPUs. So, and then the next question for you all is, how much do you use chatbots and other AI tools? Constantly. I've got Sora 2 videos in the queue right now. Sometimes, not as much as they're hyped. And rarely, my AI strategy is ignore and hope it goes away. Very interesting results. I'm not sure anyone's surprised. So the first question is for you, Jerry. Can I ask you to describe the startup culture in the late 70s and early 80s, and have things changed?
Well, as the slide said, this time is different, just like last time. How has it changed? Well, it's now a cultural meme. It's a thing. And many thousands of young people are running around San Francisco right now claiming they have a startup, when back then we would have said, I got an idea. It's become an institutionalized concept. It was not the case back then. It wasn't something that people, if I said I was doing a startup, most people would have known what I meant. You know, what are you starting up? What are you talking about? It's a company. Oh, a company, you know. So, but the bones of it, I think, haven't changed that much. The structure is basically the same in terms of the stages that you go through, the ways in which you work to reduce risk, the stages at which you raise capital. Although the scale has changed, I think that the basic process is probably the same as it's been probably throughout history for creating new corporations.
And when you came to Stanford as a postdoc for Ed Feigenbaum, did you plan personally to become an entrepreneur?
No, I wouldn't know what the word meant at the time. I was a freshly minted PhD out of the University of Pennsylvania, and it just somehow that they got the idea that they were going to take a bunch of academics and throw them into a company, and they were all going to be able to make money. And everybody thought they knew what that meant, and nobody did.
And you were originally drawn to AI by seeing 2001: A Space Odyssey.
You've read my book.
And deciding you wanted to build HAL.
Right.
Was that still true when you actually founded or Teknowledge, co-founded, and then Symantec?
Well, I think that was just a guiding star. It's just a concept. It's sort of like AGI. It's not really real, and every time you reach for it, it's just going to move further and further away. But yeah, that's what got me very interested in the subject, and it's certainly why I got interested in computers and why I got my PhD, one of the first PhDs in artificial intelligence, actually.
And then just briefly, can you tell us what was the business model at Teknowledge? And was it similar to your competitors?
Oh, man. OK. Well, the business model was fairly simple. We were going to take the work that was going on at Stanford in expert systems, you remember this, rule-based systems, and we were going to sell them, make products and sell them to corporations, and they were going to use them to solve problems, and that was the idea. The problem is it was also based on a bunch of completely incorrect assumptions, just as much of what the AI industry is today, as Daniela can probably talk about. The incorrect assumptions were that you could only do this work in Lisp. How many of you wrote programs in Lisp? There we go. OK. And in order to do it, you needed what today would be a $150,000 thing the size of a washing machine that was a single-person computer called a Lisp machine. How many of you remember Lisp machines? OK, there you go. None of that was true. And how we discovered that it wasn't true is an interesting story, but I don't want to get ahead of you on this whole thing.
We're good. So Adam, you co-founded an AI startup at a time when they were not especially fashionable. Can you tell us what it was like getting investment and interest?
We initially didn't pitch it as an AI startup per se, because while AI was big in the 80s, there was, I won't say a winter. I mean, AI continued working, but the term artificial intelligence fell out of favor in the 90s and the 2000s. So we weren't bold enough yet to say AI all the way. Instead, we pitched ourselves as a do engine. So search engines existed, but they would just give you links. And then you'd have to go do all the work yourself. And so we said, if you want to find a web page, go to a search engine. But if you want to get something done, go to a do engine. And so that was the main distinction. I will have one add-on, fast-forwarding perhaps your questions, but as many of you may have heard, our little startup sold to Apple, and Steve Jobs went on stage at All Things Digital. Walt Mossberg was the moderator, and he said, "Why did you buy Siri, that search company?" And his response was, "They're not a search company, they're an AI company." So I actually claim that Steve Jobs was the first to kind of boldly invoke the term artificial intelligence before it came out on the iPhone later on. And then just like that, AI was everywhere since then. So in the same way he kind of reinvigorated so many fields with computers for movies, for music, iTunes, iPhone with mobile, you could make claim that he saw coming this new wave of AI and was the first to kind of proclaim it thus.
And you were inspired by Apple's much earlier Knowledge Navigator intelligent assistant vision. What was your business model for Siri Incorporated before being bought by Apple?
So we were inspired by the Knowledge Navigator video. This was a concept video done in the late 80s by Apple, imagining a future. And it was really prescient because it not only imagined things that didn't exist, like an iPad-like device, the web, well before the web was a major thing, but it also had this little assistant that could know you, interact with you naturally, and do tasks for you. So, and footnote, there are those who very carefully looked at the clues of the original Knowledge Navigator, so about 86, 87 video, and you can figure out what day in the video they chose, because it was a future video, future concept. What day did they choose? There's a calendar on the desktop. There's references to years. It turns out that the day from the original Knowledge Navigator video was within 2 weeks of the launch of Siri, some like 24 years later. So coincidence? I think not. But the last footnote I'd mention, so you said you were inspired by HAL. Our first venture partner is sitting here in the front row, and the pitch that we brought him literally was called HAL. So Siri's first name was also inspired by HAL. So what was the business model? Well, it really was around that do engine concept. And I always say AI, you can think of it as knowing things and doing things. And you want both. But it's really hard to get an architecture that can seamlessly handle both, because they're very different. People will say, oh, ChatGPT's thousands of times better than Siri. I'm like, oh, really? Well, with Siri, I can say, tell my wife I'm going to be late, and it sends her a message. Does ChatGPT do that? Oh, no, it doesn't send her a message. Oh, with Siri, I can say, play my workout playlist, and it starts playing. Make a reservation tomorrow night, and it does things. So the original business model was to have an open ecosystem where every partner, think of it like an app store, where every business in the world could plug in and connect. And it would bring not only knowledge, things that it knew, but actions, things that it could do. The original Siri had 50 partners. You could buy movie tickets through Fandango or movietickets.com. You could call a taxi, say, get me a taxi to my restaurant. We didn't have Uber yet, so Taxi Magic was our partner there. So you could book, you could say, get me 2 tickets to the Warriors game tomorrow night, first preseason, or second preseason game. And it would just instantly do that for you without long, drawn-out work. So initially, we were a do engine. We were going to be an open ecosystem for all partners. And we would take a little commission fee for the transactional pieces because we were making it so easy and seamless to be able to make those transactions get done.
Amazing.
Thank you.
Amazing.
So Daniela, can you describe the current startup culture around MIT and Harvard? And does it differ in significant ways from the Valley?
Well, so let me say this. When I started at MIT, everyone wanted to be a professor. All my students wanted to advance the knowledge and be the next academic researchers. Now everyone wants to be an entrepreneur. So all my students are interested in startups, and they are on top of the extraordinary advancement that we see, and many times ahead. So it's really incredible. Everyone wants to make a difference in the world today. But what hasn't changed is this idea that the students still want to do something great with long-term reflection and thinking, the kind of time you get as a PhD student. But once you do something, it's not enough to publish a paper and go present on stage. The students really want to make that work matter today, not 10 years from today. So it's really, it's so energizing. It's amazing.
And in terms of getting investment, getting interest, I presume it's a fairly open environment to this.
Yes, we are so we have great partnerships with industry, with companies. And this works both ways, because we learn from companies what are the hard problems that they face. And then we tell the companies what's happening around the corner. And we get support from, for this kind of collaboration, first at the level of research, and then when the research starts bearing fruits, that can also turn into investment opportunities for startups. And though I do have to say that we are chagrined every time our students decide to leave the East Coast for the West Coast, because there is so much more action here. So we're working hard to fix that.
So tell me about your current startup, Liquid AI. For the audience who may not be familiar with the idea of a liquid neural network, can you explain how they are different from more traditional LLMs built on transformers?
So my research group works, broadly speaking, on robotics and AI. We're interested in getting machines to do new things in the physical world. And several years ago, we started developing end-to-end AI solutions in the deep neural network framework for autonomous driving. And we saw that our solutions were really good at keeping the cars on the road. But they made mistakes, and we never knew when those mistakes would happen. And the models were really large, and we didn't really understand how they made decisions. And so for safety-critical applications in the physical world, it is important to have AI models that do not make mistakes. It's also important to be able to run those models on device because when you run them in the cloud, latency becomes an issue, and there are all kinds of problems. And then when you have applications in the physical world, it's important to have AI solutions that understand physics. And today's solutions do not understand physics. We have very powerful AI solutions that work very well for digital applications. And in fact, you can think about the state of AI and robotics today as being two separate fields. AI works really well in the digital space. It's amazing us with its decision-making and learning. Robots have a physical presence and the ability to execute pre-programmed tasks, but they're not intelligent. So I was interested in putting the two together through what I call physical AI. And so we started thinking about alternative models for AI, and we got inspiration from nature. We got inspiration from a creature called C. elegans that has inspired a lot of neuroscience literature. And what's interesting about C. elegans, it's a small worm that has a very good life on 302 neurons, in contrast with 1 billion neurons in our brain, the billions of neurons in our brain. And so the other thing that's interesting about C. elegans is that biologists understand the math of what happens inside the neuron and on the synapses between the neurons. So we use that math and the wiring in nature as the basis for a new kind of AI model. We call that liquid neural networks. And we actually found that these liquid neural networks are very powerful, first in the research lab, and then we decided to start a company, and I'll tell you how that happened if you ask me. But what was really awesome about these, so consider this. So in the deep neural network, in the classical AI model, we needed about 100,000 neurons, AI neurons, to keep a car in lane. The car used video feedback and decided how to steer and accelerate. With liquid neural networks, we need only 19. So from 100,000 down to 19. And that's really extraordinary, because with 19 neurons, now we can actually explain how the vehicle makes decisions, how the brain makes decisions. And then we were able to prove that the solution is causal. That means it learns how to associate cause and effect, and it learns a skill rather than the context of the skill. And then you can take the skill in one environment and use it in a different environment. And this actually allows for generalization, the kinds of things that you may have heard that today's transformers are not so good at. So we were very excited about this new model, and we saw a lot of energy savings. So we can train these models about 1,000 times more efficiently than we train other models, and we can achieve much more with with a much smaller size than in traditional models. And so basically that's how the research developed. We started from the car. We wanted a safety critical solution, one that we could understand. We got inspiration from biology, and then we developed the math of this model.
So what are some of the applications then that you're envisioning? And further down the road, what's the business model for this for your company.
So the company then got started. You're not asking me about how we started the company.
So how did you start the company?
Okay, so I gave this interview to the Quanta magazine. And
Oh, it's
I
a
was
great
not
magazine.
It's great, but you know, part of our liquid network solution is that we could actually get a closed form approximation to the differential equation. And so the journalist kept asking me, what does it mean to have a closed form solution? And so we went over and over and over again that answer. And so I was actually a little bit anxious about how this article would turn out. But it turns out that the article was extremely well received. The journalist wrote a wonderful and very clear article. And then we got a call from a VC who said, I think you guys should start a company. I'll give you a bunch of money. I'll take 10%. And if you don't do anything, if you don't get any solutions that have business impact, it's okay. But I think you are onto something, so go for it. And so I spoke with my students and postdocs, and we thought, yeah, that sounds like an interesting opportunity. We should go for it. And so that's basically how we got started. So I want to say a deep thank you to the journalist who wrote that Quanta article.
And the VC
and asked many questions about closed form equations. Okay, so we really want AI that can run on the edge. With this model, we can cope with any kind of applications that have time series data. That means we have data that comes in sequence. So text, for instance, is an example. Financial transactions, speech, video. A lot of data comes as a sequence. So you can imagine building. I mean, don't imagine. You can look up the results on Liquid AI on the Liquid AI website. But we basically produce very high quality models that are very energy efficient, 100 to 1,000 times more energy efficient than other comparable models in size. And these models are very performant, and we can characterize how they make decisions, and they have a very small memory footprint. So that means you can take these models and you can put them on your phone or on your computer or on your sensor or on any kind of what we call edge device, so that they can run on-prem. This means you do not need the cloud calls, and that enables more private engagement with your AI model. And from these properties, we can really imagine sort of democratizing AI. Right now, the AI solutions are really dependent on the premise that we're going to build larger and larger models that sit in industrial scale installations. And with AI that can run on-prem, then all of a sudden you don't need those industrial scale installations. And it's a little bit like what happened in computing when we moved from mainframes to PCs.
Right.
So when we had mainframes, the access to developing computing was limited to the companies that could have the mainframes. As soon as the PC was introduced, all of a sudden, boom, all of a sudden we had such a flurry of activities and the field of computing really exploded. And so just imagine what could happen if AI is less expensive, less energy intensive, if you can have each one of you AI on your phones, and you can engage with it privately without the cloud calls and without the big energy costs. And so that's really exciting. And I haven't answered your question about applications. So now imagine AI running in your car. Imagine you can engage with AI independent of the cloud call. That means if you go through a portion of the roadway where you do not have coverage or you have high latency, you can still rely on your AI. You can think of your AI now as your personal friend. That can turn your car into a friend, and you could still engage. And with cars, it's really problematic when you have dependency on the cloud calls, because even like a 10-second delay in getting the answer could make a big difference if you're driving at, say, 60 miles an hour. And you can imagine putting AI in this kind of AI in hospitals, where it's really important for the data to not go to a third party. And you can imagine so many other things. Just think about putting AI on your fridge, on your appliances, on your luggage, on your phone, on many devices that we haven't even invented. I think there is such a great opportunity as we think about a world with more democratized access to AI.
Jerry, as you listen to this, how different is this kind of vision than what you guys were thinking about expert systems, a very different form of AI many decades ago for the applications?
Well, the thing about the expert systems that you have to understand is that the technology was not good enough for the things it was promised to do. It just didn't work for that. So that's why the whole thing collapsed, is it was a bunch of people in AI, mostly academics, promising something which they had no clue how to get done, and it wasn't adequate. So that's a completely different situation than what Danielle is talking about today.
But the promise, were some of the dreams as ambitious?
Well, sure. I mean, the promise of artificial intelligence has always been this pot of gold at the end of the rainbow, which today is known as AGI, that we'd have general purpose machines, sort of like the HAL 9000, which murdered the crew of its, which I always was very impressed with that myself. So, I mean, this whole concept goes back to, Carol Kopek, and he invented the term robota, I think was the Czech name for robotics. And his whole idea, what was the name of the book? I've forgotten now. Okay, sorry. Rossum Universal Robots. Rossum.
I mean,
that was probably in the modern context, and that had been in very early 1900s, probably in 1906 or 1907. I'm going to get this wrong, and I'm going to get 100 emails about it. But I mean, that was where this whole idea of, actually goes back to the Frankenstein monster. It's the same thing. We're going to create something that has human-like characteristics, and in doing so, it's an abomination, and we're all going to die as a result. It's going to kill us. So this whole, it's a mystical notion that's rooted in long historical a history of the way in which people think about new technologies and their effects. But that certainly came through all the way from the start of the AI revolution to today.
And Adam, when you co-founded Siri, you guys were in a more applied kind of time for AI. I mean, were you thinking in some of the, revolutionizing the way that we deal with every kind of technology in the way that either before or after people were?
We were really looking at the problem of language and how to make it practical. And, it seems so trivial to humans because we're really, really good at language. But back then, I think we shocked the world when we came out with Siri. The fact that for a broad set of domains with tens or hundreds of millions of vocabulary words that can combine in just an unbelievable number of ways, that you could pull intent and language, understanding out of all of those possible combinatorics and then do it in a dialogue, conversational way, I don't think anyone, of course there were research systems going way back, and my first version of a Siri-like system was in 1993 before I saw a web browser, but to do it at that scale was, I think, new. I'll give you one example I often use. If I say, I want you to book a 4-star restaurant in Boston, everyone in this room knows what it means. But if you think about it, there are 13 Bostons in the United States. The word book not only means make a reservation, not only is it a physical book, it's also a city name in the United States. And Star is a city name in the United States. So which city are we talking about? And Star Restaurant is the name of a restaurant. But we're not talking about a restaurant name here, right? And there's just infinite possibilities when you add in, we loaded in business data. Like we had a system that was working pretty well, and we loaded in 50 million business names, and I realized every word in the English language is a business name. Like, I remember typing start over, and it said, looking for businesses named Start in Over, Mississippi. I'm like, what happened? Right? And we had to drag ourselves back and out of that piece. So for me, one of the big innovations was how to do language well. Another innovation was how to do it in a way that was extensible by domain, so third parties, any business, could do it themselves without being a linguist, without being an expert from expert systems, be able to use tools. How to do this in a conversational dialogue way, and then how to execute the actions and learn from those behaviors of kind of what we would call agentic today. All of those things were in what we did with Siri, and I think those are the major things we were focused on at that time.
Could I briefly comment on that?
Sure.
Sure, if you don't mind. The history of natural language processing is really the history of expanding context.
Yes.
And this, I can talk before Siri and I can talk after Siri, but what people are experiencing today with the chatbots is primarily a result of taking that same kind of basic context and expanding it to an extremely large extent to thousands and thousands of...
I agree.
Okay.
Absolutely.
Yeah. And Danielle, Liquid AI is currently in trials, is that?
It's what?
Currently in market trials?
Yeah, we have customers.
I mean, can you talk a little bit about what you're actually applying it to now?
Yeah, I mean, we have some upcoming announcements. So I cannot talk about that just yet, but I can tell you we're very excited we have a range of customers in retail, in the auto industry, in the hardware industry. And we have also a lot of customers who are interested in taking the models and solving problems within their business on device. Quite recently, maybe about a month ago, we started releasing some of the models. We open sourced 350 million parameter model, sorry, 350 million parameter model, the 700 million parameter model, 1B, 2B, and I think 7B are all open source now and openly available for research and for people to play with them. We also showed a lot of interesting data on, for instance, translation. So we showed that these small models are the best, fastest in the world and the best in the world at doing, say, Japanese language translation or real-time translation between languages, and we showed that within the context of certain tasks, our 350 million parameter model has the performance of GPT-4o, and so you can imagine there's a huge difference in size between 350 million parameters and the GPT-4o. Also, we gave memory footprint data, and we gave energy consumption data. And so all of these really point to a kind of an approach to AI that addresses different types of problems than what transformers address. So transformers are still very important, and the big models are really essential, because the size of the model really captures the amount of information that we can store in the model, and the model can only work with the information that gets memorized in it. And but with Liquid, we have a different type of reasoning. We call them the methodology physics-based AI rather than statistics-based AI. And that allows our models to reason about physical phenomena with much better accuracy and clarity than other models. So these models can be, so we work with customers in multiple ways. We can prepare a model that's designed for the customer and for the application at hand, or we can empower the customer to build their own applications using our models. And so, I mean, this is, at the moment, it's a B2B kind of a play. And it's been super exciting to see the traction. I have Liquid running on my phone, and I can show you extremely fast operation in complex settings. Like, I could take a picture of this room, and Liquid will describe everything in the room with great accuracy and great detail using words. So the models are also multimodal. We also use the models for drug design and for financial transactions. And so the future is great. Just think about the AI computer, the iPhone, the AI anything.
And wanted to ask all of you which is more important, technology or timing?
Timing.
Or any? Timing?
Yeah, I would say timing. I'm very proud to have created the first largely disseminated voice assistant. Many came after. I was founding member of change.org, the first social network for social activism. Many came after. Sentient was one of the first large-scale machine learning platform companies with more than 2 million CPUs and GPUs, just as deep neural nets were coming up. And Viv did some innovations about dynamic program generation. It was one of the first large-scale AI systems on hundreds of millions of devices that would write code to hand an answer. So I've tried many things at different times. You can be too early and you can be too late. And one thing I've been lucky or good at is hitting the timing just right.
Danielle?
I admire greatly my preeminent colleagues on the panel, but I'm going to disagree.
Yes.
And I'm going to say that timing without technology to bring to the world, what does timing mean then? So I think technology has to be there. I think we have to develop technology. We have to think about new ideas that bring new capabilities to the world. So I believe in technological entrepreneurship. Meaning that you develop a new piece of technology, and then and that is the technology that makes a difference and becomes the foundation for billion and trillion dollar businesses. Now, having said this, I will say that it's hard when you come up with something completely new. It's really hard to get the rest of the world to see or to align with your imagination of what is possible and to back your ideas. So maybe I'm coming around and saying, yes, timing is also important.
Marc, if you were a VC in the Valley, and I think we've got a couple in the audience tonight, and you've been listening to pitches for the last 30 years, one of the things you would definitely notice is you get the same pitches over and over and over again. I'm getting some nods here for the people who can't see this. So what you begin to understand is the environment, the business environment and the technological environment have to be ready at the right time. It's like surfers all lined up waiting for a wave to come to shore.
Exactly.
One of them is going to be at the spot where the wave is going to break. And that's why I'm saying timing is important. Anybody can get on a surfboard, but being on the surfboard when that wave breaks, that's the difference.
Excellent. So, do all of you agree that this time it's different?
I'll take that. I'll take that. Well, I mean, as I said before, it's different just like last time, but there are some real differences, and it depends on what you're talking about. I'm referring to the AI bubble. Well, we're in the middle of an enormous economic bubble, and when it breaks, it's going to be really bad, and not just for people who are in AI, it's going to drag down the rest of the economy. And there are real reasons why that's going to occur. So this time is different. I've lived through 4 bubbles. 2 of them, including this one, is an AI bubble, and they all have exactly the same structure. The same kinds of things occur, and I can just sit here like clockwork, watching these same principles happen. We've got 3 or 4 companies taking their revenue and investing it in other companies on the thesis that those people are going to buy their products. I'll give you $100 million, but you have to buy my CPUs, my GPUs. Now, that happened in the internet boom. I watched it. I was sitting right there, and I will tell you something. It's illegal, and it's a form of financial fraud. So what we're seeing is this process of this thing feeding on itself, and when it collapses, it's going to be very bad. Now, the last time in the internet boom, there were hundreds of millions of dollars. Now we're talking about hundreds of billions of dollars. Well, that's going to have real societal effects, and it's going to affect everybody in this room. And it's going to be a very ugly process when this whole thing begins to unwind, and in that sense, this time is different.
Oof. And jobs. So who would like to, is AI going to augment or replace human jobs or something totally different?
Well, I teach about this all the time, so I could.
Quickly then.
Very briefly, the AI revolution right now is an advance in automation. And automation is about the substitution of capital for labor. And it always has exactly the same effects. It makes us wealthier, and it changes the nature of work. And it is true that some people are going to lose their jobs, but it is also true there will be new kinds of jobs that will arise. And the nature of how you do your job is already in the process of changing because of the new AI technologies that we have. And the people who learn how to employ the new technology in order to do productive work for real companies that have real economic value, those are the ones that are going to do well in the future. The important thing to understand is every time there's a technological innovation, as we're in one of those periods right now, people say, oh my God, everybody's going to be out of work. Well, here we are at full employment. Hundreds of years of these kinds of revolutions. The only thing I can promise you is there will be plenty of jobs in the future. They will just be different than the jobs that we have today.
So can I add to this? I just want to give you a number. My colleague, David Otter, who is a prominent economist at MIT, has studied this problem, and he actually has a really compelling number. He says that more than 60% of what people do today did not exist prior to 1948. So think about it. This is really incredible. And so I actually agree, and I would say that the problem is that it's really much easier to think about what will go away than to have the imagination to see what will come. And so, for instance, when everyone was working in agriculture in the United States, they did not imagine, people did not imagine the service industry. that generated so many more jobs than there are today. And frankly, you know, I mean, I'm sure many of you remember the year 2000. We were just talking about that. In the year 2000, or around that time, there was such a boom in computing. And there were so many companies, so much activity, and yet nobody was talking about smartphones, cloud computing, and social media. These three technologies all came in 2007, and now they employ so many people. And they employ not just us, the geeks. I imagine that we're mostly geeks in this room. I'm a proud one. So not just geeks, right? So there are artists, there are content generator, there are people with all kinds of skills and talents that are not necessarily computing skills and talents, who are now part of this economy as a result of these new technologies. And so I really see, I don't see AI going away, and I do see a lot of, like a large flurry of activity, of economic activity around AI. And, but what's important is that the public begins to develop some AI literacy in this moment in time. Getting more knowledge about this technology, how it works, and how to use it is super important. And not everyone needs to understand the math and the nitty-gritty of how it all works. And so depending on your role, whether you're a leader or a user of AI, or a developer of AI, or a deployer or decision maker, you will need to know of, different things, but it's important for people to get empowered with this kind of knowledge. It's important for people to have some kind of course understanding of how it works, and in particular, because the core of this technology is statistical, understanding what it means to understand the output of a statistical decision engine is super important. And so I think there should be AI courses in the medical school and in the legal profession, and all across the board.
Adam.
I'm going to answer the "is this time different" question, as opposed, I think the jobs question was covered well. I will say it is different, but there's a lot of parallels and lessons we can draw from the previous bubbles. Why do I say it's different? When a new technology comes up, I always ask, does this allow us to do something, solve a real-world problem that we couldn't have done before? And I think most technologies, many technologies, the answer is no. Like quantum, we have more and more qubits. Have we reached that moment where we've solved a problem that we couldn't with a normal supercomputer? You know, blockchain, does it allow us to do things we couldn't do with database? Maybe, maybe not. We can debate. But with AI, I think already it's clear that there have been problems solved. So there were several 50-year math problems, unsolved math problems that were solved with the help of AI. Protein folding is an example where we had just a fraction of understanding about how proteins will fold in shapes, which is important for drug discovery. Now it's basically a solved problem. This is new knowledge that humans can now use to compute and solve problems we couldn't have before. And so I acknowledge all the problems that it may bring, but overall I'm an optimist, and I do say that this tool, and it is a tool, may be the most important tool humanity's ever created because of this ability to work so broadly across applications, to be able to attack these wicked problems. You know, climate change, hunger, poverty, war, all of these are problems. AI will bring its own set of problems, but if it can be used to potentially solve some of these big problems and help humanity approach it, I'm generally optimistic. So I will say that, you know, yes, the internet changed things for good and bad. Yes, mobile changed things for good and bad. Personal computer did as well. But for me, this is maybe the most powerful tool humanity's created. And I'm excited about the future.
So may I add? That was very nice. So I just want to add that the AI for scientific discovery is real, and you see it in every field, not just in computer science. You see it in physics, in chemistry, even in history and in literature. And so this is really amazing. So we are advancing the knowledge, but we're also empowering individuals and organizations and communities and society. And we're empowering, and we have evidence with actual contributions and examples of how AI is empowering us with speed, with knowledge, with insight, with creativity, with foresight, with mastery, even with empathy. And so if you think about just how we can enrich our lives and how we can look after humanity after the future generations, but also after the planet itself, because that's really very important. I think it's extraordinary. And the other thing I find really extraordinary is how unique we are, we humans. Right? Like, we are the only species so aware, so capable of building these incredible tools. But this also comes with an obligation, with a responsibility to figure out how these tools can be used for the greater good, for humanity and also for the planet.
And we need to move to the Q&A, and I want to point out that you've actually just answered. So one of the first questions was, what should a 9-year-old fourth grader learn to have the skills and knowledge for the future where AI is everywhere? And I think you guys have addressed a lot of that.
So I think it's important to learn about programming, about computational thinking, and about AI. But it's also important to continue to learn the regular subjects.
Definitely. And also, a question about academia and commercialization. But sorry.
Well, look, there are two critical skills for the future, because this is the question we always get. One of them is the ability to understand how to use, not how it works, but how to use this new technology to employ it for practical purposes. The other thing is, interpersonal skills are going to be much more important in the future than they've been in the past, because those are the professions that are not going to be as heavily impacted by this particular technology. So teaching people how to work, interact socially, to express authentic empathy, to understand what other people want, and to interpret and to interface with other people, that will be the second skill that's going to be important for that 9th grader or whatever it was to learn.
Fourth grader.
Fourth grader. Okay, well, then it's a different story.
So does the progress of AI necessitate a universal basic income? Anyone?
No.
Choose. Who wants to answer? We'll do one at a time.
Well,
Adam? Or?
I think people enjoy working. I think work gives people a certain sense of purpose. And so I think it's important to continue to have that sense of purpose. And I don't know if we cultivate that with a universal basic income.
Adam, why has Apple had so much trouble bringing better intelligence to Siri today?
So I'm no longer with Apple, so I can't actually answer that. I will only give a few hypotheticals. I know they're a much larger team. We were 100 people all in when we launched the first version of Siri. I know there are many thousands today. And we had a very clear vision. We knew exactly what we were going to do and why. From the first day we met our first investor, we had a plan and we knew where it was going to go. And I haven't seen externally a clear vision on how Siri should evolve. And so I'm hoping I love Siri, I love Apple, and I want them to do well. Hopefully, a clear vision will help steer this very large team.
So I'd be remiss if I didn't say liquid AI can really help.
Have computer scientists finally built the tools to put themselves out of a job?
No.
No.
I must say, though, the way I approach computer programming is different now.
Very different.
So to Jerry's point that every job is going to change, and coding in particular is the one field I'm like, there's no way it's going to work well. Large language models will work well because every little nit, and there's so much unique things going on in a program. And yet every day I'm blown away. I'm blown away at the nuances and the subtlety and the artificial intelligence of the response. So, our jobs will change, but I think computer scientists and programmers will still be needed.
Do you vibe code?
So if you buy that, if you mean, do I use AI to help me in programming, then yes, absolutely.
So you use the tools like Cursor or Replit or...
Sure, I've used all of them, and I use some of my own, but it is at a point where, to your point about understanding the probabilistic outputs, statistical outputs, sometimes it'll make mistakes, sometimes, but humans make mistakes. I made a mistake today, and I asked a question, it goes, oh, by the way, you might want to correct this piece, and I'm like, oh my gosh, you're right, that's wrong. So working with an AI as a co-pilot while you code, I think is shockingly and surprisingly to me useful.
Jerry?
I would just say that in my experience, it's very useful, but you still need the human problem solver.
Oh, absolutely. It will not replace
you.
the
It doesn't
human,
replace you.
but it will
Jerry had something to... Yeah.
Programming is a form of expository writing. And what it is, the key skill is the ability to clearly express yourself in the language that's being provided. Now, I've watched us go through generation after generation of language, and each one built on top of another. If you're writing in Python today, it's being translated into C. I remember when C was a high-level language. I remember when assemblers were high-level. I remember, all the way down. Unfortunately, I watched the whole stack get built. Expressing yourself clearly in natural language is a form of programming. And so the programmers of the future are those people who can express their thoughts and ideas clearly and explain how they should be implemented and accomplished.
And how will AI tools change relationships with other people and AI?
I'll say how I would like it to change. One thing I think AI can do to help. So today, I don't know if you've noticed, when you go online and social media, today's algorithms, it feels so divisive. It feels like black and white, good versus evil, us versus them, etc. I think AI can be used to bring people together by highlighting the commonalities and diminishing the differences. And we all have commonalities. We're not doing it today, but I think a next generation of AI can do this. If I love basketball, I can walk into any gym in the world, and I'm with brothers and sisters. It doesn't matter what race, what religion, what politics. I make a good pass, we are connected and bonded for life, right? So this is one way that I think AI can be used to help foster more togetherness, stronger relationships.
I made plenty of passes in my time, and they didn't always work out well.
And a question for, this actually was from John Markov, but Jerry and Adam, what would your advice to today's founders be?
Today's what?
Founders. Different perhaps than when you founded those first companies.
I'll start. So one, I did not do a company just because I wanted to do a company.
Exactly.
I was working on, Siri for 18 years from first version to when it launched on the iPhone. I was doing it anyway, repeatedly, because I was interested and passionate about it. So I think if you enter entrepreneurship with the desire to be an entrepreneur, to start a company, to make money, you're likely not going to succeed. If you enter it because you're curious, you're interested, you're passionate, you see a vision that you're like, I think, with Siri, I was like, I think this could be really good. I see it, I use it, I like it. I think the world will like it. How do I find out if the rest of the world also thinks it could be good? Well, a company is the best way to get there. So for me, that would be my advice. Do it because you love to do it. Don't do it because you want to be an entrepreneur or start a company or make money.
I agree with Adam 110%. I never started a company because I wanted to start a company. I always had to start a company because I couldn't get whoever I was working for at the time to finance the project that I thought was going to have that is what's wrong with the startup culture today. Hey, I'm going to be a founder. I'm going to start a company. Let me see, I got to go find a good idea somewhere. Let me go find some co-founders. Let me read about how this process is done. That's a little bit like saying, I want to have a really great wedding. I guess I got to go find a spouse. Anybody want to marry?
So I'm excited because both of you are advocating technological entrepreneurship.
Absolutely. Absolutely.
So are LLMs going to be the death of search engines? And that's the last question, I think.
I think yes. I mean, just how they'll change. You still may want to find that web page, but really, how often are you going to that web page because you want to find it? Today, it's about, search engines were always about knowing. How do I find the page and read the information? And doing. I think as AI evolves to support both, search engines will only be useful for getting to, the page exists and you want to go there for some particular reason. But for knowing and doing, I think LLM++, liquidified or whatever, will replace most of our usage in search engines.
The way I would put the same thing is that LLMs are search engines. What you're doing is you're searching a database that's an amalgam of a significant portion of human knowledge. Now, if that human knowledge is in the form of all the text that's ever been written, that happens to be the way what you're searching now. But if later versions or enhancements to the LLM technology are constantly being updated by what's happening on the web, that'll be the database that you're searching.
True, all that is true, but the LLMs consume so much more energy than a straight-up search. So if we really care about our energy costs and about the planet, then we need to make the LLMs much more energy efficient or find a kind of a balance between when we use a full AI solution or something simpler, something less energy hungry.
Well, you could take that point of view, but that's an economic question. How much does it cost you to get the answer? Is there somebody who's willing to provide it for you at that cost?
I did say LLM++ liquefied. So.
Great. Do we have a last Slido poll for the audience?
They're going to change their mind.
Well, it looks like this time it is different.
Just like last time.
Yeah, thank you.
Thank you so much.
Yeah.